frequent stools. In English, diarrhea. Why would she be having lots of diarrhea? What's that tell you about her intestine?
It's stretching too.
It's stretching. Why was it stretching again? Let's go to the first page. What was that lymphocytic cellular infiltrate meaning? Remember the question 3 on the first page? Lymphocytic cellular infiltrate meant what? White blood cells. And why are white blood cells in my intestines?
She has a bacteria.
I have an infection. What do bacteria do to my intestines? They stretch them. If you ever wonder why you get diarrhea with the flu, as the flu chews on your intestines, they think they're stretched. They're going to push as fast as they can to blow it out as quickly as they can. So she's getting diarrhea because her intestines are getting stretched. They push and push and push. Out comes water. Does that make sense? More fiber, more speed.
So it has nothing to do with goblet cells producing more fluid?
And they would also do that too. So if you get an infection, they just dump everything they got into the lumen. The bacteria chewing on you, you got more fluid, that's going to make everything stretch, and you just keep pushing until everything's out. A lot of E. coli actually will make your intestines leaky, so water starts coming in as well, and that just raises the stretch even more. And so they get the water, plus the stretch, plus the irritation, plus everything. Yes? Yes? Okay. And one little activity for you that's not in your packet. It's the last one we're doing for tonight. We'll talk about your exam. So we'll do as a class. It's a new one I'm trying. So you're my second guinea pigs today. Is that right? No.
Nutrition, activity. I'm tired. I got one.
I'm really behind the time, aren't I?
I just haven't slept a couple days.
I'm going to show you a PowerPoint on investigative learning.
Poor Kristen. She's going to be like,
Now everybody in the class
Let's
is
walk
looking at
through
me.
this little activity. I was originally going to give this like a homework, but you have an exam, so I'm not doing that. We're going to walk through some of these. There are some articles at the top. If you're curious, if I'm making this up, you can go read. But there's been a controversy in nutrition that basically everything you're learning is, other than stuff I taught you, is probably wrong. So there's two guys. Walter Willett is one. He's at Harvard Medical School. He's arguing that everything you learned is wrong. And then there's a guy by the name of Derek Bassett who's arguing something. Let's go through Willett's idea. He suggests the only thing that matters about your diet is the GI, which is the glycemic index. He says really nothing else much matters. So let's figure that out. What is a glycemic index? It's how fast you raise your blood sugar. So let's figure that out. So name a food you think might be high glycemic index.
White rice.
White rice is one. What else?
Potatoes.
Potatoes, French fries. What else?
Candy.
Candy, Snickers bar. Give it to your kid, 5 minutes. Bam, there you go.
Honey.
Honey. Right. So name something that might be a low GI food.
Spinach.
Broccoli, spinach. Steak. Right. Oils. Something that doesn't raise my sugar. So let's make a graph. Here's what Willett is suggesting. I'm going to do a graph of blood sugar over time. Let's say I eat 3 Snickers bar, which are a high GI food, right? It's easy to break down, immediately hits my blood vessels. What would happen to my blood sugar graph if I ate Snickers bars? Go up. How fast would it go up? Very quickly. How far would it go up? Right now. Black. Okay. We know negative feedback. What does the body do if something spikes up like that? I want to bring it down. So from last term, how does my body bring down blood sugar? Insulin. So I'm going to crank out insulin. How much insulin am I going to crank out? A lot of insulin. How fast? As quickly as I can. So I'm going to do what they call an insulin flood. Your body thinks you basically overdose on candy. Boom. Okay, let's review last term. Is insulin steroidal or non-steroidal? Non-steroidal. What does that mean? It needs what? It needs receptors. Okay. So tell me, what does a lot of insulin do to receptors?
Burns them out.
It does. How does it burn them out?
Overuse.
Overuse. Remember physical addiction. If my receptors keep getting yelled at, they shut down. So eventually, my receptors turn off to insulin. So what happens when I have high blood sugar and I don't have receptors for insulin anymore? My blood sugar stays high. We call that what? Diabetes. So in type 2 diabetes, he's arguing the cause is you made so much insulin to counteract this quick sugar, you fried your receptors, so you no longer hear the insulin. So in type 2, you're making insulin, you just don't listen to it.
But I thought candy bars and potato chips were a good lunch.
They are.
Every day.
They're a great lunch. That and a Coke Classic, it's the American dream. Breakfast champions, donut and a Coke. Yeah. It's good. Especially if you like this. Right? So Willett's argument is that type 2 diabetes is simply because of high GI foods. So let's do a low GI food, like some kind of whole grain concoction. Okay, what would my blood sugar do if I ate a low GI food? Slowly, okay. So let's do it hypothetically. Right? Okay, so how much insulin does it take to do that? Not as much. So I get a little insulin. So a little insulin does what to receptors? No problem. Same receptors. Just use them and that's fine. So his argument is spiking blood sugar causes type 2 diabetes. Things with low GIs don't, because you don't get the spike drop effect. You don't get physical addiction to the insulin. That's what you're essentially doing. Does that make sense? Okay, that's his argument. So you can read it. Okay, so let's do number 5 then. We kind of went through these. So remember, type 2 diabetes is also linked to lack of exercise. Yes, Tom?
Would that, I mean, you would describe that as being physical addiction.
It's the same idea, yes.
Is it going to cause you to want to eat those foods more frequently?
Yes, actually it does. In type 2 diabetes, what happens when you burn the receptors, the cells don't get fed. So your cells begin to secrete warning signs to the liver to say, I'm starving. So your liver makes glucagon to try to raise even more blood sugar, because the liver thinks you're not eating enough. So then your body blood sugar goes up even higher to try to counteract the cells that are starving. And then you're worse. So they call it starving in the land of plenty. The sugar can't go in the cells, so the cells actually die from lack of sugar.
So I wonder if your body's used to doing that with particular types of food, if you're more likely to crave those particular types of food.
Such as?
Well, I was actually thinking about beer, believe it or not.
Weird.
Honestly, I don't know. I'm just going to let that one slide. Let's do this number 5, something I can't answer. Lack of exercise leads to type 2. So tell me why exercise would reduce the effect of the GI. I'm using up my sugar. If I exercise, I use the sugar quickly. Why? For what? For energy. So I'm using it up, so my sugar levels stay a little more moderated. So it takes a little less likely to burn it out. You're going to use the sugar as soon as it hits your body. So put your children in front of their Xbox with a soda and have them sit there all day long. What will happen to blood sugar? Spike. Put them on a treadmill, no spike. Okay? So sedentary lifestyle amplifies the effect. You're not burning sugar. Make sense? So that's Willett's idea. He has another idea. Let's go down to question 6. His argument is that cholesterol has nothing to do with heart disease, unlike lipid and statins. Here's his argument. If cholesterol affected heart disease, everyone that has high cholesterol should have heart disease. Right? But he's finding cultures that have high cholesterol and no heart disease. Can anyone guess what cultures that might be?
Eskimos.
Eskimos, believe it or not, yes. The Amish.
Hunter-gatherers.
Hunter-gatherer sites. So let's figure out why that is. What does the Eskimo eat?